Hey guys, here's Prajwal with another video solution on one of the binary tree problems from LeetCode. So this one is based on a binary search tree. So in case you don't know what a binary search tree is, so binary search tree is a binary tree in which all the nodes satisfy a property. The property is, suppose I'm considering this node 8. Now for this node, all those nodes falling to the left subtree of 8 have their values less than the node value, that is 8. And all those nodes falling to the right subtree of 8 have their values more than that node value. That is, in case this property is satisfied to all the nodes in my binary tree, then such a tree is called a binary search tree. Now let's jump into the problem description. So we are given the root of a BST and the lowest and highest boundaries as low and high. We are asked to trim the tree in a way that all its elements lie in that boundary. That is, we might also need to change the root of the tree and return that new root of the trimmed BST. So let's consider a few examples. So here's a binary search tree with 3 nodes, 0, 1 and 2, and the boundary they've given is 1 to 2. Now we have to trim or remove or discard all those nodes from the tree which do not fall in this boundary. That is 0 is one of them and the only one in this example. So we remove 0 and this is the resulting BST. Here's another example. Here's a BST with 5 nodes and the boundary is from 1 to 3. So all those nodes which do not fall in this boundary, which fall outside this boundary, that is those nodes having values less than 1 and more than 3, are to be discarded. That is 0 and 4 are removed or trimmed from the BST, resulting into a skewed binary tree or a binary search tree of this form. Okay. One more thing to note is that we might also have to remove or trim the root itself, and while returning we must make sure that we are returning the new root of the trimmed binary search tree. So here are the constraints. Let's take a moment to look at the constraints. Okay, so before we jump into the solution of the problem, we need to keep few things in mind. That is, whenever you are presented with a tree problem, we must be sure that most of these solutions to tree problems are recursive in nature, although they could be solved iteratively, but intuitively, since the definition of tree itself is recursive in nature, most of them have a recursive solution. And once you start designing the recursive solution, one thing you must keep in mind is you do not have to consider the entire picture of the tree while you build the recursive solution. It is enough you consider a node at a time, a node with just its immediate left subtree and right subtree, and try to build a solution for that. What I mean is, you just consider a node here and just consider its left and right immediate subtrees and try to build the recursive solution for this node only in general. Now the rest of the things will obviously be handled by recursion. Okay, so on similar lines, let us consider a node and let's try to build the recursive solution for it in a way that recursion will obviously handle the rest of the tree. Okay, so when with a given problem statement, what we are given is low and high, and we need to trim all those values or nodes in the tree which fall outside this range, correct? So let me consider the given node, as I said, and for a given node I see 3 possible cases. One is the value of that node can lie in that boundary, that is case 1, and the value could lie outside the given boundary, that is outside. What I mean is, it could be less than low or it could be greater than high. Do we have any other cases except these? No, these are the 3 cases. Now let's see how we individually solve or recursively build the solution for considering these 3 cases. Okay, so let's take the cases where the value of the node lies outside the boundary, that is case 2 and 3. Okay, so let me take the second case, that is my value and the value. Suppose that low is 5 and high is 12, a small example, and case 2 is value less than low, that is suppose I take 2. Now it is clear that 2 shouldn't be a part of my resulting BST because I have to trim it since it does not lie in my boundary. Also, what do you think about those nodes which fall to the left subtree of 2? Since it's a binary search tree, all those nodes lying to the left subtree of 2 will obviously have a value less than 2, correct? Now when they have a value less than 2, since 2 also shouldn't be a part of the resulting BST since it doesn't lie in the boundary, obviously even all the nodes in the left subtree shouldn't be a part of our answer. So we must be trimming both 2 along with its left subtree, correct? So let's similarly consider the other case when the value of the node is higher than 12. Even in that case, 17 for example, it should be trimmed along with all those nodes which fall to the right of that node, because all the nodes which fall to the right will obviously have a value greater than 17, correct, which don't belong in this boundary. So we must trim both 17 and all those nodes which fall to its right subtree. So that's case 2 and 3 for you, correct? So let's actually code these. Okay, what we just saw are two cases where the value of our node is less than low and greater than high. So in that case we should consider only the remaining part, that is we should process the right subtree in case 2 and the left subtree in the third case. Let's do that on code. So if my value is less than low, what I do is I consider my right subtree. I should ignore myself along with my left subtree. That means I should recurse for the right part, right? So my answer will be the same as whatever my answer would be of my right subtree, root of right, low, high, correct? Similarly, if my value is greater than high, then I should ignore myself as well as the left subtree, and my answer will be the same as the answer of my left subtree, correct? This is case 2 and case 3. So it's nothing, it's whatever cases 2 and 3 that we discussed. Okay, so the remaining case is when the value of the node lies in the boundary. Okay, so for example 8, it lies between 5 and 12. So in that case what we must do is we must consider it. We should not trim it. It should be a part of the answer, right? So we won't be trimming it and we will recurse further to both the left and right part, including the node under consideration. So it simply means to recurse further, right? We trim BST of root of left, recursing to my left part, and I should also recurse to my right part. Trim BST of root of right, low, high. Should I return anything? I should return myself obviously in this case because I am a part of the answer. So since I lie in the, apart from this case, the case is myself lying in the boundary. So when I lie in the boundary, I should be a part of the answer. So I should return root, right? So what is the stopping case? The stopping condition would be obviously the base case, in which my given node being null, that is if root is equal to null, I will return null, right? Looks good. Yeah, so we've considered all three cases here. The first two lying outside the boundary, and then if it lies in between, then I should be a part of the answer and I recurse further to my subtrees. Okay, so let me try to run this code. It's showing me some error here. Okay, I'm missing a, yeah, Oopsie, another error. Okay, I'm root of val. It's missing. Yeah, it's taking it now. Let me try to submit. Yes, it's accepted. So that's it. That's for the solution for trim a binary search tree on problem 669 on LeetCode. Thank you.